Hi guys, my name's Catherine. I'm one of the tutors here at Chegg. I typically tutor science, English, math, and Spanish. And today we're going to be talking about a science topic, which is atoms, molecules, and chemicals. So everything that you have ever seen is made up of atoms. Gases, rocks, everything that's alive, everything that's dead. If it's stuff, it's made up of atoms. And obviously that also includes things you can't see, like you don't see the air around you that you're breathing, but that's still made up of atoms. It doesn't include things like light or gravity. But like stuff, it is. Like if it's stuff, it's made up of atoms. So this here, the periodic table, is a list of all of the known atoms. And so they're organized. If you go across the table, the number of electrons, which are things that circle around the center of the atom, increases. So this has the least number of electrons, and if we go across, we get more and more and more as we go, like that. Also, if you go down each column, the number of electrons in the outermost shell of electrons is the same. So let's draw a picture so that I can give you a good example. So let's use sodium. So the abbreviation for sodium is Na. Don't ask me why. And we see here that it has an atomic number of 11. Let me circle it. Atomic number 11. This one right here. Okay, so because sodium has an atomic number of 11, we know that when it's in its normal state, it has 11 protons and 11 neutrons. Oh, I'm going to make that smaller. Or even, let's do this. 11 protons and 11 neutrons. Neutrons are neutral and protons are positively charged. But the sodium atom that we have here doesn't have any charge, or at least not right now. So if we have plus 11 on the inside, we need to have a negative 11 somewhere to balance that out. And where that comes from is the electrons. Electrons are negatively charged. Now, electrons don't stay in any sort of specific pattern that we can see. They kind of just like whiz all the way around the center of the atom, which is also called the nucleus. But we like to draw them in circles because that helps us to understand their energy levels. Because it is true that some electrons are at a lower energy state than other ones. So their innermost shell of any atom can hold at most 2 electrons. So we're going to draw the 2 here. 1, and we'll draw it on the other side. So that's 2. And just so that we can keep track of the shells, I'm going to draw a circle like this. Yeah. So that's the first shell, right? And it's got the 2 electrons right there. The next shell can hold 11, 11 is the total. The next one can hold 8. So there's our second shell. Oh, and we are going to draw on it 8 more electrons. 1, 2, 3, 4, 5, 6, 7, and 8. And like I said, they don't stay in shells like this. It's not nearly this organized, but this just helps us to see it better. So total right now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But like I said, sodium has an atomic number of 11, so we need 1 more. This next shell can also hold up to 8 electrons, but as we can see, we only need 1 more. So that's going to go right here. And so that is an uncharged sodium atom right there. But as you see, there's 1 extra electron in the outermost shell, and it's at the highest energy level. The closer electrons are to the inside, the lower their energy level. So this guy right here has a ton of energy, and he's super far away from the nucleus, so he doesn't feel as much pull to stay there. So it's likely that he's going to hop off and go to join another atom. So let's look at the table again. I don't know if you can see it from here. Let me see if I can pull it over at all. Okay, so it's super small, but right in the corner here you can see that chloride has an atomic number of 17, right? Okay, so that didn't help because now it's covered up. Yeah. So chloride here has an atomic number of 17. So let's draw that right here. So 17 protons and 17 neutrons, and it's going to need to have 17 electrons to balance it out. So just like sodium, we're going to have, let me draw these first so that I know I can fit everything. 1 and second shell, and then we're definitely going to need a third shell because 17 is more than 11. Okay, so let's just draw the electrons on it really fast. Make these red. 1, or, well, let's not, because to be fair, they're the same. Electrons are electrons. It's not that like sodium electrons look different than chloride electrons or something like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 1, 2, 3, 4, 5, 6, and 7. And actually, just to make drawing it a little easier, I'm going to move that one and put the, oh, actually, that kind of made them a little too small. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, we're just going to leave it like that. So here, this outer shell, because there's 2 plus 8 is 10, plus 7 is 17. So its outer shell has 7 electrons. And here, the outer shell has just 1. Like I said, the outer shell can also hold, or the third shell can also hold 8 electrons in any atom. So what's likely to happen is that this electron here is going to jump, and it would probably be less of a jump than this, to be fair, but over to this one right here. And the 2 atoms are actually going to bind through this. This is what's called an ionic bond, because it's not even sharing this electron anymore. This electron ends up entirely in the sphere of this atom, the chlorine, rather than that of the sodium. So this is how you get NaCl, also known as table salt. So there's other ways that you can have sharing of electrons. Sometimes rather than it taking the electron all the way, 2 atoms will share the electron. So that's what's called a covalent bond. And that's not as strong, but they're still pretty strong. An example of an atom that has covalent bonds inside of it is water, or H2O. And that looks, we'll draw it here really fast. Where you can see here, this is water. H, atomic number of 1, oxygen, oh here, atomic number of 8. And I'm not going to draw the whole thing out, but H has 1 electron total. Oxygen, like we said, has a total of 8 electrons, so it has 2 in the first shell and 6 in the second shell. So 1, 2, 3, 4, 5, 6. And it'll get the 7 that way, 8. Or rather, what I'm going to do, because that's not the best way to draw it, let's do this instead. So we're going to still draw this here, but what we're going to do instead, so 1, 2, 3, 4, 5, 6 in their outer shell. The reason I drew it this way is because these 2 are going to share those 2 electrons and share these 2 electrons. So through that sharing, this hydrogen has 2, 1, 2. This hydrogen has 2, and this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So everything fills their shell. So this is how you get molecules. So what molecules are is just a combination of 2 or more atoms together. And that's essentially what chemicals are too. Anything that's a chemical is also a molecule. Sometimes you'll hear people say something like, oh, don't eat that, it's full of chemicals. And what they mean is it's full of artificial stuff. But that's probably not the best way to say it, because everything is full of chemicals. You're full of chemicals, vegetables are full of chemicals, the air is full of chemicals. They're everywhere, and they're not necessarily good or bad. So that does it for a quick lesson in atoms, molecules, and chemicals. I hope that you enjoyed this lesson. And if you have any questions, feel free to contact me for private tutoring on Chegg.